Hello, let me take you through logarithm. I know maybe some students might be getting some few challenges in logarithm. So what are the first steps that you need to have or to follow so that you get this concept of logarithm very clearly? One, the student has to know the laws of logarithm. Now, what are the basic laws of logarithm? So let's look at the basic laws of logarithm. One, we know that when you are multiplying logs log a times b, it is the same as the log of a plus the log of b. Two, when you divide the log of a over b, then it is the same as having the log of a minus the log of b. Three, when you have the log of a raised to b under any base here, this is the same as b multiplied by the log of a under the base x. Four, the student also has to realize that when you have the log of a, then base a is always equal to 1. You know, they are simple basic laws. 5, the log of 1 of any base here is equals to 0. Basic laws of logarithm. And also, we have the log of a base e is the same as the natural log of a. And 7, we have to know that if you have the log of b base a can be written as the log of b over the log of a under any base. You can choose your base here under any base. Alternatively, the students can also say the log of b base a is equals to, you can also say that if you want to change the base and the value here, you can just say it is equals to the log of a base b. Okay, so these are basic laws of logarithm, and when you have them, then things becomes easy. Now, I have this worksheet, and let's go through it. Let's go through this worksheet. I've picked some questions from each section here. Now, I'll be doing one question. Now, if you have a question like this, the log of 25 plus 5 is equals to 1. Remember, you can change logarithmic notation to exponential notation or index notation. So this is just like asking yourself, how many times are you going to multiply 5 so that you get 25? It is 2 times, 5 times 5. In other words, a student can say, you can just write here, it is 25 is equals to 5 raised to y. You can see here, 5 raised to y. And for you to get this, you know that 25 is 5 squared is equals to 5 raised to y. And you see that the bases are the same, so which means y is equals to 2. And that is your answer. So can you attempt these other questions in that particular section? In question 2, if you look at it, it's almost just like the question 1. I have picked question 4 here. In this question here, when you have 16 log base 48, especially this one, can be simplified. The above can be simplified. So how can we simplify the above? So what we do here, we can use various, the law number 7. If you look at the law number 7 here, can also be applied there. So if you have the log 8 base 4, we can now say here that let's take the power first. We can just say it is just like the log of 8 over the log of 4. We can just make them to be under base 2, okay, for us to get the solution. So log 8 base 2, you know that when we have log 8 is just 2 raised to 3 under base 2 is when this 3 is multiplied down here, we get 2 log 2 base 2, and you know this one is 1. This is 3 here, sorry. So then for the log of 8 base 2, the answer is 3, which means for the log of 4 base 2, the answer is 2 because 4 is 2 squared. So the answer for the power is 3 over 2. So which means we can now say that it is 16 raised to 3 over 2. Now, when 16 raised to 3 over 2, you know that the denominator means the root. So it means the square root of 16, then to the power 3, which means that you get 4 to the power 3, which gives you 64. So 64 is your answer for that particular question. Okay, so when you come to question 10 here, we know that this question can be written in form of the log of x cubed y squared over z raised to 4. Then this one can be written over, that is under power half. So the power half can be brought down here, multiplied here. Then you have the log of x cubed, and remember the laws of logarithm. When you're multiplying, what do? You add. So that is log that, and then what do you have? So before you add, let us just write them first, multiplied by this, and then we have the raised to 4. Then now open the brackets, so we have a half. Then now expand them, is x cubed, then plus log y squared, then minus, because we are dividing, log z raised to 4. So this one under the bracket, because a half takes care of all of them. Now you can bring 3 down. When you bring 3 down, then you have 3 over 2 log of x, then plus, this will be 2 over 2, which is 1, because you're multiplying by a half. Then we'll have log y minus, multiply 4 times a half, which is 2, then the log of z. And that is your answer for that particular question. Then, when you go to 4, then you use the basic laws of logarithm and indices. So, which means that we are going to write it in exponential form. So the log of 1 over 64 base 4 is equals to negative 3. We said that these 3 can just raise that. So you get 1 over 64 is equals to 4 raised to negative 3. And that is it. And that is the end. Write the following in logarithmic form. So changing to the index notation to logarithmic notation. Remember, this is our base, this is our value, this is our logarithm. Okay, that is the way we do it. So, which means it is, you write a logarithm under the base, which is a third, and the number is 27 is equals to the logarithm, which is negative 3. And that is it, and that is the answer for that. So you can try these other questions. Now, this is proof, true or false, and this is part of AAHL, you see, proving. So we can prove this by saying that just using laws of logarithm, just saying this, what you have here, can be written as negative natural log, 1 over x. 1 over x is the same as x raised to negative 1. Okay? 1 over x is the same as x raised to negative 1. So if you multiply down here by a negative, which means negative times negative is equals to positive. So this is the same as natural log of x, which is the same as the natural log of x, so which is true in that particular aspect, okay, because this negative here will multiply by that particular negative. Okay, so if you come to question 7 here, this is some of the questions that becomes challenging to students. So what you do first here, first step is to convert. This is 1 to be under base 9. Make sure that the bases are always the same. So if you convert 1 under base 9, it is the same as 9 under base 9. So any number, log a base a is 1. So 1 is converted under base 9. So when you have done that, then you can now use laws of logarithm. You factor log base 9 here. So you'll have x minus 5. This addition, then it is now multiplication, is equals to this other side is equals to log 9. Okay, so you can cancel out the logs, and then you can have x minus 5, x plus 3 is equals to 9. So you expand this one and solve, and then you get the values of x. Okay, so when you expand, what do you get? You get x squared, that is minus 5 and 3, you get negative 2x, then minus 15, bring 9 from the other side is equals to 0. So which means you have negative x squared minus negative 2x minus, this is 24 is equals to 0. So you can solve the values of x, and I believe we are right, because this is 3, this is 5, that is negative 2x squared, and then negative 15, negative 9. So when you solve this, you will get your values of x. Okay. Now when you come here, you need now to prove the statements. And remember, this is now AA, where you come in, proof. This is what makes you different from AI, because you have several proofs. Remember, we said here that if you need to prove, you need to do the following. So what we have is the log. Remember, that one is the same as the log of a half. Then x, is it the same as 2 log bx? That is what we need to prove. Is this one the same as this? No, raised to this. And we said, what the student has to do, you have to use simple laws of logarithm. You say the log of x over the log of b raised to a half under any base. So we can choose base b for our convenience sake. Then you can just say that above you get log of x base b over, down here you can see you can multiply a half on this side, then you will have log of b base b, this one becomes 1. So you remain with a half. So log x base b divided by a half is the same as 2 log x base b. So we have proved that it is true. That is how you prove. Okay. This part can be done by the student because it is only substitution there, and also maybe to emphasize on this part, when you have this form of equations, the easiest thing is substitution. Just substitute. Okay. Just substitute. So you say let y is equals to e raised to x. So then we will have y squared minus 2y, bring 15 from the other side, is equals to 0. Okay, what are the factors? So you get that it is 5, it is negative 5 and 3. So you have y squared negative 5y plus 3y minus 15 is equals to 0. So this is how you solve this, so that you get it's y minus 5, then y plus 3 is equals to 0. So which means y is equals to 5 and y is equals to negative 3. And remember we said e raised to x is equals to y. So then you say is equals to 5. So we can get the value of e. So which means you can say that the natural log, so we can say x is equals to the natural log of 5. Okay, because you use the natural log on both sides. And then you say that the second one, the e raised to x is equals to negative 3, then you say x is equals to the natural log of negative 3. And when you talk about the natural log, we have the natural log of negative, so we find that we deal with the positive, logarithm. So this one you can use your GDC and see how the graphs behave. This one you can use your GDC. And also finding the inverse, this one we can do it later during your curriculum. So maybe attempting these questions when we have done compound interest can be of great assistance, but you can still try them. Now, in all these questions that we have done, these extra other questions, then the student can get the solutions down here. So all the solutions are down here. You can just go through them. The solutions are here. Okay, you can screenshot them. All the solutions for the questions are here. So you can attempt the questions and look at the solutions down here. You know, either the true or false. All the solutions are down here. You can see them just for the inverse, and the other part you can skip, but you can do the rest of the questions. The solutions are here. And the last part of the question, then you get this is for the inverse. Those who have read ahead, you can try, and this is the last part of the word problems that we have. Thank you, and let's meet again in the next video.